Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 151, reverse words in a string. Given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return a string of the words in reverse order concatenated by a single space. Note that S may contain leading or trailing spaces or multiple spaces between words. The return string should only have a single space separating the words. Do not include any extra spaces. So let's look at some examples. We have this string here, the sky is blue. So obviously we want to return blue is sky the, because obviously that's the reverse order, right? Blue is sky the. Here we have hello world with some extra spaces, and we see that we want to return world and then hello. And we want to disregard these spaces. So this problem is relatively straightforward. What we want to do is we want to parse out the words, store them in some sort of list, and then simply return that list backwards and concatenate it with a single space in between each of the elements. So that's really what this problem is going to boil down to. The first part of it is simply going to be to parse each individual word, right? Parse words, and then we're going to basically just return reversed, right? Reversed string. So the way that we're going to do this is that we just need to go through the string from left to right and parse out each individual word. And what we're going to do is we're going to store it into a string builder. So for example, we're going to have, okay, so we're going to parse this S, and we're going to say the, and then we can parse sky, and then we can parse is, and then we can parse blue. And then what we want to do is simply reverse this list. So now it will be blue is sky the, and then we simply want to join this string builder and then just return the final answer, right? So it'll be blue is the blue is sky the, let's see, sky the, right? And that's going to be how we do it. Now we could make an optimization here because you notice that we have to reverse this string. If we actually used a double-ended queue, then we could just be appending to the beginning each time. Instead of having to append to the end of a list and then having to reverse, we could actually use a deck, which will actually still be, big O of n space complexity, but that way we would actually save a reversal. So we can do a little bit of a micro optimization there and kind of use a data structure that we know will give us that nice insert at the beginning. Because remember that inserting into a list at the beginning is going to cost big O of n, so our time complexity would actually be higher because of that. Anyway, enough rambling. Let's go to the code editor and write this up. The code is really simple and easy to follow, so I'll see you there. Welcome back to the code editor. It's time to write the code. Remember that we're going to need a string builder to store our result, which we're going to return at the end of our function here. So let's define that. So we're going to say string builder. And I said that we're going to use a deck. And the reason that we want to use a deck here is that we can actually append to the left in constant time. And by appending to the left instead of to the right, like a normal list, our input will actually be in the correct order when we finish processing our string. And we won't have to reverse it because we can just keep appending to the front, and it will actually give us the same result as if we reversed a normal list with these words. So we can save one iteration there because obviously reversed will have to go through the entire string builder to reverse it. So we can save one parse through. So now what we want to do is we want to find all the words in our string. And the way that we're going to do that is that we're going to identify a start point for a string, and we're going to continue right until we hit a white space. And then that means that everything from that start index up until the index of our current, white space will be the word. And remember, since in Python, string slicing, the endpoint is not inclusive, it will get the entire string there. So that's the approach that we want to take. So we're going to need a variable to keep track of starts of words. So we're going to say start initially is going to be equal to -1. And we need a pointer to keep track of where we are in our string, so that way we can move it up accordingly. So we're going to say while I is less than the length of s, we're going to say if we're not at a white space, then that means that we are starting a word. because every time we start a word, we're going to go to the end of it. So that means that either we're at a white space or we are simply starting a word and we need to now process it. So if we have a white space, if we don't have a white space, then we need to do some processing. So we're going to say start equals to I. And then now we need to go to the right until we hit a white space. So basically we're going to parse out the entirety of the string. So we're going to say while I is less than len s, and so basically we want to make sure that we don't overdo the string. And then while s of I does not equal to white space, so while there's still characters to parse, we want to say I plus equals to 1. Now when this loop breaks, either we're at the end of the string or we have hit a white space. In this case, we need to just parse the entirety of whatever was there between our start and the current I pointer. So we're going to say string builder dot append left s start up until I. And remember, I is not inclusive, so if we're at the end of the string or we're at a white space, it won't include it. So that is why we have that. And then now we actually need to do a I minus 1, because we're going to have a global I plus equals to 1. So if we didn't have this here, we would skip 2 iterations whenever we have a non-white space character. So we want to make sure that we don't accidentally skip something. So that's the reason why we bring it down 1. And now this will process our entire string. And at the end, all we need to do is simply just return our input, right? And it just needs a 1 space delimiting them. So we'll just say, white space dot join, and all we have to do is join the string builder. And that's how you solve this problem. Let's submit it, make sure we didn't make any bugs, and cool, we solved it. So what is the time and space complexity for this algorithm? Well, the time complexity, all we do is go from left to right through our string. So this is going to be a big O of n solution, because all we have to do is just go from left to right through our string and process out the words. So what is the space complexity? Well, our space complexity is going to be dependent on the length of the words in string. In the worst case, we won't have any white spaces, right? Our string will be like A, B, C, D, E, F, like basically the alphabet characters, right? All the way down to like X, Y, and Z. And there's no white spaces. So we would have to store every single word here, this entire word, in our string builder. So it's going to end up holding, S. So that means that our space complexity is going to be big O of n in the worst case. So that is the time and space complexity for this algorithm, and that's how you solve this problem. It's a pretty simple question, not really a medium in my opinion, but whatever, Leetcode calls it a medium, so it's medium. Anyway, if you enjoyed this video, please leave a like, subscribe to my channel, and if you want me to make any videos, please leave them in the comment section below. Let me know any topics or video numbers you want me to solve, and I'll be happy to get back to you on that one. Just let me know what you want to see, and I'll be happy to do that. So otherwise, thank you for watching. Have a nice day. Bye.